Hello everyone, welcome back to the channel. I'm Teacher Jay from Kangaroo Study. In today's video, we'll be continuing on the remainder problem. In our last video, we have covered about the basic case about the remainder problem. Do you still remember? In that problem, we have some questions like this. You are given a number of pairs. If you pack them 9 in the bag, then you'll have 3 more. Now if you pack them 5 in the bag, you'll be short of 1. We are trying to find out the smallest possible number of these pairs. Now if you forget about it or you haven't checked out our previous video, take a look at this video first. Alright, today we'll be continuing on this type of problem, but we will be covering about the common remainder case. It is a special case. So without further ado, let's go. Now before looking at the question, let's take a look at an example first. Let's say I have a number. This number, when it is divided by 5, it has no remainder. Similarly, when it is divided by 3, also has no remainder. Now, we are trying to find out the smallest number that satisfies these two conditions. How can we find this out? Now let's take a look at the conditions one by one. For the first condition, when divided by 5 has no remainder, that means what? That means our number is a what of number 5? It is a multiple of 5. So now the number, it should be a multiple of 5. Similarly, when divided by 3 has no remainder, that means it is a multiple of what? Of 3. So again, our number, it is a multiple of number 3. So our number, it is both a multiple of 5 and a multiple of 3. So it is a what of 3 and 5? It is a common multiple of 3 and 5. So now our number here, it should be a common multiple of 3 and 5. But not only common multiple. We are also trying to find out the smallest number. So we are trying to find out the least common multiple of 3 and 5. How can we find out the least common multiple of two numbers? Very easy. You can pick the largest number first, list down the multiple of it, and then you check if it is also a multiple of another. This time, 3 and 5 is larger, so we pick 5 first. We list down the multiple of 5. The first multiple of 5 is, of course, is 5. Then we check, is it also a multiple of number 3? 5, of course, is not a multiple of 3. Then we check the next multiple of 5. The next one should be number 10. Is this a multiple of 3? Again, no. So let's cross it out. The next one should be 15. Is this a multiple of 3? Yes, this is a multiple of 3. So 15 is the least common multiple of 3 and 5. Now, this number, it is the least common multiple of 3 and 5. So our answer here is just 15. Alright, now if you understand this, let's take a look at a more challenging question. This time, the number, when it is divided by 5, it has a remainder of 2. When also divided by 3, it has a remainder 2. Again, we are trying to find out the smallest number that satisfies these two conditions. How can we find this out? Okay, let's see. Of course, we can use the method we used in the previous video. We pick the constraint first, and then we list down the possibilities, and then we check with another constraint. That is called the list down method. This is workable. But in this video, I'm going to tell you a more smarter way, a small trick here. You see, in the previous example, if there is no remainder, we already know the answer is 15, right? But now, in the second example, there are some remainders. So let's think about this. Can we convert this example into the example we know previously? That is, can we try to make this into an example without remainder? How can we do that? Let's think about this. Here, when divided by 5 has to remainder of 2, That means it consists of the number of 5. The last number should always be a number 2 here. Similarly, our number when divided by 3 has a remainder 2. That means our number, it can consist of a list of 3 here. And the last number should be what? Should be a number 2 here. Alright, now how can we try to remove our remainder here? How about let's do a subtraction here. Now after we minus this number 2 to our number, what will happen? For the first constraint, let's see. After we minus 2 to our number, we still have a remainder 2 after divided by 5? No more. Similarly, let's check out our second constraint here. After minusing 2 to our number, will we still have any remainder after divided by 3? Again, no more. So after minusing 2, our number, it is a what of 3 and 5? It should be a least common multiple of 3 and 5. Now we already know that the least common multiple of 3 and 5 is just 15. So that means our number when minusing 2 equals to 15. What is our number? Our number is just 15 plus 2 back equals to 17. So that is the answer to this example. So see, in this example, this is called a remainder problem because in both of these constraints, we have some remainder. Now, in the remainder problem, what we try to do is we can convert this into the multiple problem as seen in the previous example, in example 1. Now, how can we convert this? If you have the same remainder, then you can minus the remainder to our number. Then you'll get a complete number, that is no remainder. So let me write down the summary here. In summary, now in the remainder problem, our idea is to convert this into the multiple problem. Now, how to convert it? If you have the same remainder, then we just minus the remainder. Alright, so that's the summary to this question. Alright, now if you understand this, let's take a look at the word problem here. Now, City has some pairs. When she packed them in bags of 9, there are 3 pairs left. When she packed them in bags of 5, there are also 3 pairs left. What was the smallest possible number of pairs that City had? Okay, let's try to interpret these conditions line by line and convert this into mathematical equations. Now, when City packed the pairs in bags of 9, there are 3 left. What does that mean? That means the number of pairs when they are divided by 9 has a remainder of 3. Similarly, when she packed them in bags of 5, there are also 3 pairs left. What does that mean? That means the number of pairs here when it is divided by 5 also has a remainder of 3. We are trying to find out the smallest possible number that satisfies these two conditions. Again, based on our previous observation, we can try to convert this into the multiple problem. How can we convert this? You see, they have the same remainder over here. So if they have the same remainder, we can minus this remainder. Now, our number, when minusing this remainder 3, see, after minus 3 to the number, oops, let me erase this first. After minus 3 to our number here, our number, let's check out the first constraint here. After divided by 9, will we still have a remainder 3? No more. Now similarly, after divided by 5, we also have a remainder 3. Also no more. So after minus 3 to our number it is a after minusing 3, our number it is a least common multiple of 5 and 9. Now what is the least common multiple of 5 and 9? To find this out, we list down starting from the multiple of 9 first. The multiple of 9. The first one is 9, of course. Then let's check, is this also a multiple of 5? Of course not. Then we move on to the next multiple of 9, which is just 18. Is this a multiple of 5? No. The next multiple of 9 equals to 27. Again, it's not a multiple of 5. And then the next one should be 36. Again, no. The next one should be 45. This time, yes. So the least common multiple of 5 and 9, it should be 45. So our number when minusing 3 is 45. What is our number? Our number is 45 plus 3 back, which is equal to 48. So that is the answer to this question. So let's do a quick summary for this question. You see, in the remainder problem, when we try to convert this to a multiple problem, if we have the same remainder, then we just minus this remainder. Right? If you understand this, let's take a look at a very similar question over here. If you have finished this question and want to check out the answer or want to discuss with us, then just feel free to scan this QR code and join our WhatsApp group. And if you like this video and want to check out more interesting contents, feel free to click the button below and subscribe to our channel. With that, it's time to say goodbye. I'm Teacher Jay, and I'll see you in the next video. Bye bye!